Look up at the night sky, see the twinkling stars? Many are not alone. They have partners dancing around each other in a cosmic ballet. These are binary stars, two stars locked in a gravitational embrace. Imagine two stars far out in space forever circling each other. Their movements are graceful, their interactions powerful. Binary stars are more than just beautiful sights, they are cosmic laboratories. Scientists study binary stars to understand gravity, stellar evolution, and even the search for life beyond Earth. Their study unlocks secrets about the universe we live in. Join us as we journey into the heart of binary star systems. We'll explore their mysteries and discover the crucial role they play in the grand cosmic narrative. What exactly are binary stars? Simply put, they are two stars that orbit each other. They are bound together by gravity, an invisible force that pulls them towards one another. Imagine two people holding hands and spinning around. That's similar to how binary stars move. They are constantly pulling on each other, creating a graceful swirling dance. The center of this dance is not one star or the other, but a point in space between them called the barycenter. Both stars orbit this point. Binary star systems are incredibly common. In fact, more than half of the stars in our galaxy likely have a companion or more. They come in different varieties, each with its unique characteristics. Not all binary stars dance the same way. Astronomers have classified them into different types based on their orbits and how we observe them from Earth. Visual binaries are systems where we can see both stars with a telescope. They appear far apart in the sky, slowly orbiting their common center of mass. Eclipsing binaries are systems where the stars pass in front of each other from our perspective. When one star blocks the light of the other, we see a dip in the system's brightness. Spectroscopic binaries are systems that are too close together to be seen as separate stars. Astronomers identify them by the Doppler shift in their light, which changes as the stars move towards and away from us in their orbits. Some binary stars are so close that they touch. These are called contact binaries, and they share material and energy. Their dance is a close embrace, influencing each other's evolution in dramatic ways. Binary stars are born from the same cosmic womb, giant clouds of gas and dust called nebulae, but how do two stars end up bound together in a celestial dance? Imagine a swirling cloud of gas and dust collapsing under its own gravity. As it shrinks, it spins faster and faster like a spinning figure skater pulling in their arms. This spinning cloud can fragment into smaller clumps, each destined to become a star. If two of these clumps are close enough, their mutual gravity can capture them, forming a binary system. Another way binary stars can form is through capture. Imagine two stars initially traveling independently through space. If they pass close enough to each other, their gravitational interaction can slow them down, capturing them in orbit around each other. Section 5. Life cycle of binary stars. Just like single stars, binary stars go through a life cycle of birth, evolution, and death. These systems are formed from the same nebula, a cloud of gas and dust, which collapses under gravity to form two stars instead of one. However, the presence of a companion star can dramatically influence this journey. The gravitational pull between the two stars can lead to fascinating interactions, such as mass transfer, where one star can pull material from its companion. The evolution of a star depends on its mass. Larger stars burn through their fuel much faster than smaller ones, leading to different evolutionary paths. Massive stars live fast and die young, often ending their lives in spectacular supernova explosions. In contrast, less massive stars can live for billions of years, slowly burning their fuel. In a binary system, the more massive star will evolve faster, reaching the end of its life first. This can lead to a variety of outcomes depending on the distance between the two stars and their respective masses. When a star runs out of fuel, it expands into a red giant. This phase is marked by the outer layers of the star swelling up and cooling down, giving it a reddish appearance. If it's in a binary system and its companion is close enough, the red giant can engulf its partner. This can lead to dramatic changes in the system, including the potential for the two stars to merge. This can lead to incredible events like stellar mergers or the creation of exotic objects like white dwarfs and neutron stars. These remnants are incredibly dense and have fascinating properties. The life cycle of binary stars is a complex and fascinating story. Each system is unique, with its own set of characteristics and evolutionary paths. By studying these systems, astronomers can learn more about how stars are born, evolve, and die. This knowledge helps us understand the universe and our place within it. Section 6. Stellar vampires and exploding stars. Binary stars can exhibit some of the most dramatic and energetic events in the universe. These systems consist of two stars that are gravitationally bound to each other, often leading to fascinating and sometimes violent interactions. Their close proximity can lead to interactions that are both beautiful and destructive. The gravitational dance between these stars can result in the exchange of stellar material, creating stunning cosmic phenomena. Consider the case of stellar vampires. These are white dwarfs that siphon material from their companion stars, a process that can dramatically alter the fate of both stars involved. In some binary systems, a white dwarf, the dense remnant of a sun-like star, can pull material from its companion star. This process is not only fascinating but also crucial for understanding stellar evolution. This stolen material can build up on the surface of the white dwarf, eventually triggering a thermonuclear explosion, a nova. These explosions can outshine entire galaxies for a brief period. In even more extreme cases, a white dwarf can accrete enough material to exceed a critical mass limit. This is a delicate balance, and when it tips, the results are catastrophic. This triggers a catastrophic explosion called a Type Ia supernova, one of the most luminous events in the cosmos. These supernovae are so bright that they can be seen across vast distances in the universe. Binary stars can also create gravitational waves, ripples in the fabric of space-time predicted by Einstein's theory of general relativity. These waves carry information about the most extreme environments in the universe. As two massive objects like neutron stars or black holes orbit each other in a binary system, they create these ripples that travel at the speed of light. These gravitational waves provide a new way to observe and understand the universe. Section 7. Finding binary stars. Astronomers use a variety of techniques to find and study binary stars. Some are relatively simple, while others require sophisticated instruments and telescopes. Visual binaries, as the name suggests, can be identified by directly observing the stars through a telescope. If two stars appear close together and move in a way that suggests they are gravitationally bound, they are likely a binary system. Eclipsing binaries are detected by measuring the brightness of a star over time. When one star passes in front of the other, the total brightness of the system dips, creating a characteristic light curve that reveals their binary nature. Spectroscopic binaries are identified by analyzing the spectrum of light from a star. As the stars in a binary system orbit each other, their light is alternately red-shifted and blue-shifted, creating a telltale pattern that reveals their presence. Section 8. Binary stars and exoplanets. The study of binary stars has important implications for our understanding of planets beyond our solar system, known as exoplanets. In some binary star systems, planets can orbit a single star in the system, much like the planets in our own solar system orbit the Sun. However, the gravitational influence of the companion star can affect the planet's orbit, making it more elliptical or even ejecting it from the system altogether. In other cases, planets can orbit both stars in a binary system, in a configuration called a circumbinary orbit. These planets would experience two suns in their sky, creating a truly alien environment. The discovery of planets around binary stars has challenged our understanding of how planetary systems form and evolve. It suggests that planets can form and exist in a wider range of environments than previously thought. Section 9. Unlocking the secrets of the universe. Binary star systems are more than just celestial curiosities. They are fascinating and complex systems where two stars are gravitationally bound to each other, orbiting a common center of mass. These systems can vary greatly in their characteristics, from the distance between the stars to their relative sizes and masses. They are powerful tools that allow astronomers to probe the fundamental laws of physics and the evolution of the universe. By observing the interactions between the stars in a binary system, scientists can test theories of gravity and stellar dynamics in ways that are not possible with single stars. By studying the orbits of binary stars, astronomers can determine the masses of stars with incredible accuracy. This is because the gravitational pull between the stars affects their orbits in predictable ways, allowing precise calculations of their masses. This information is crucial for understanding stellar evolution, the processes that govern the birth, life, and death of stars. Knowing the mass of a star helps scientists predict its lifespan, its future development, and its eventual fate, whether it will become a white dwarf, a neutron star, or even a black hole. Binary stars also play a vital role in the study of cosmology, the science of the origin and evolution of the universe. They help us understand the distribution of mass in galaxies and the behavior of matter under extreme conditions. Type Ia supernovae, which occur in some binary systems, are used as standard candles to measure cosmic distances, allowing astronomers to map the expansion history of the universe. These supernovae are incredibly bright and have a consistent luminosity, making them ideal for measuring vast distances across space. The study of binary stars continues to yield new and exciting discoveries. With advancements in technology and observational techniques, astronomers are uncovering more about these systems than ever before, revealing the complexities and wonders of our universe. As we delve deeper into the mysteries of these celestial pairs, we gain a greater understanding of the universe we inhabit and our place within it. Each discovery brings us one step closer to comprehending the vast and intricate cosmos. So next time you gaze up at the night sky, remember that many of those twinkling points of light are not alone, but engaged in a cosmic dance that has captivated astronomers for centuries. These binary stars, with their intricate orbits and dynamic interactions, continue to be a source of wonder and inspiration for all who study them.